Every monumental bridge deck begins deep within nature. In the limestone valleys of Guizhou, ultrapure silica sand and high-grade iron reserves are identified for extraction. Heavy excavators harvest raw mineral aggregate from certified deposits, gathering the foundational components needed to formulate specialized, high-density concrete matrices. Quality control starts at the origin. Geologists sample and grade the raw quartz sand to ensure exact grain uniformity before transport to the casting facility. Raw materials arrive at the automated mega facility, entering a strictly controlled industrial ecosystem engineered for high-precision bridge component manufacturing. Conveyor systems distribute thousands of tons of raw minerals into climate-controlled storage silos, keeping materials dry and ready for microsorting. Precision vibrating screens separate aggregate into precise particle sizes. Only grains meeting exact geometric tolerances are selected for the concrete formulation. In the cleaning bay, high-pressure washing jets strip away organic debris and microdust, ensuring flawless chemical bonding during the mixing phase. Once thoroughly washed, the material passes through thermal drying ducts, eliminating residual moisture that could alter the precise water-to-cement ratio. Inside planetary mixers, silica powder, active polymers, and microscopic steel fibers are combined, forging an ultra-high-performance concrete 5 times stronger than standard material. Automated sensors monitor moisture content, temperature, and material density in real time, guaranteeing exact chemical consistency for every batch produced. Simultaneously, high-tensile steel plates enter the robotic processing line. Automated plasma cutters slice structural components with sub-millimeter tolerances. Multi-axis bending machines shape high-tensile steel rebar into complex internal skeletons designed to withstand immense torsional stress. The completed rebar cage is positioned inside a precision steel mold. Hydraulic clamps seal the enclosure, preparing it for high-density casting. Overhead distribution hoppers pour the liquid concrete mixture into the mold, enveloping the steel skeleton completely without leaving air pockets. The filled molds enter thermal steam chambers. Accelerated curing under controlled heat and humidity rapidly brings the concrete to maximum design strength. Robotic diamond grinders level every joint face, creating an ultra-smooth connecting surface that ensures perfect alignment during field assembly. Post-tensioning anchor plates are cut by CNC lasers, providing exact mounting points for high-strength steel cables that will support the bridge deck. Hydraulic tensioners apply thousands of tons of force to internal steel tendons, pre-stressing the concrete structure to maximize load capacity. Despite heavy automation, human expertise remains vital. Master technicians manually verify every critical attachment point with calibrated instruments. A specialized waterproof epoxy compound is applied by hand across matching joint surfaces, creating a protective barrier against weather and moisture penetration. Finishing craftsmen meticulously hand-dress edge contact surfaces, ensuring even load distribution when adjacent segments are joined across mountain spans. Quality assurance begins with non-destructive testing. Autonomous ultrasonic crawlers scan the interior of every concrete block to detect microfractures. Engineers analyze real-time subsurface cross-sections, confirming zero air voids and perfect internal steel strand alignment before certification. Laser scanning systems map the entire exterior geometry, verifying that segment dimensions match digital BIM models within fractions of a millimeter. Sample units undergo rigorous stress testing under simulated seismic and wind loads, guaranteeing structural integrity in the harshest mountain environments. Once inspected, segments receive protective polymer coatings, safeguarding the concrete against atmospheric corrosion. Acid rain and freeze-thaw cycles. A permanent serial code is stamped onto every module, linking the physical segment directly to its digital fabrication history and quality audit records. Digital tracking tags are affixed, logging the component into global logistics networks for real-time tracking from factory floor to canyon site. Sensitive connection points and pre-stressing anchorages are encased in protective marine-grade wrapping to prevent moisture exposure during transport. Fully prepared and protected, the giant bridge module is rigged for transfer, ready to leave the fabrication bay for its journey to the gorge site. Massive overhead gantry cranes hoist the completed deck segment out of the casting bay, beginning its transition from factory manufacturing to field deployment. Specialized multi-axle heavy transport trailers maneuver into position underneath, engineered to distribute 100 tons of prefabricated concrete across dozens of computer-controlled wheels. At the river port, segments are secured onto heavy river barges, taking advantage of deep-water inland waterways to transport structural components through rugged mountain terrain. Dock crews secure every segment with heavy steel tie-downs, ensuring total stability against river currents and wind resistance during transport. The barge navigates mountain river networks, carrying prefabricated bridge decks toward deep canyon construction zones inaccessible by standard highway transport, arriving at the canyon site directly below the bridge tower. The segment aligns with the main lifting cables of the gantry system, suspended hundreds of meters above. High-capacity strand jacks begin the vertical lift, raising the massive concrete component hundreds of meters out of the gorge toward its final position. At deck level, precision alignment sensors guide the segment into position, matching shear keys and internal ducting to within millimeter margins. Heavy hydraulic pullers draw the segments together, squeezing the structural epoxy layer to form a seamless, monolithic bond across the bridge deck. With stay cables attached and anchored into the segment, the bridge deck extends further across the abyss. One precision-crafted module at a time, tensioning jacks apply exact multi-strand forces, transferring the immense weight of the newly installed segment directly onto the towering steel stays. High-pressure grout is injected into the internal cable ducts, completely sealing the post-tensioning tendons against moisture and preventing corrosion. Robotic applicators lay a specialized waterproof membrane across the deck, shielding the concrete substrate from extreme weather and heavy traffic abrasion. Automated welding units fuse heavy steel expansion joints at key intervals, allowing the colossal structure to safely expand and contract with seasonal temperature swings. Autonomous inspection drones sweep the underside of the newly extended span, performing optical audits on every lower connection plate. Specialized technicians install dynamic vibration dampeners on stay cables, neutralizing wind-induced oscillations and ensuring long-term structural stability. Module by module, the twin cantilever deck spans approach one another across the 800-meter gorge, advancing toward the final closure point. Under specialized night lighting conditions, the central closure segment is lowered into place, bridging the final gap between the two mountain cliffs. Hydraulic locking pins engage across the central joint, permanently uniting the two cantilever arms into a single, continuous structural ribbon. As dawn breaks over the valley, the canyon span stands complete, a testament to precision engineering, advanced material science, and seamless prefabrication. With the structure fully joined, heavy vehicle fleets conduct dynamic load tests, verifying that deflection responses across the precast segments align perfectly with theoretical models. Thousands of embedded fiber optic sensors stream continuous strain, vibration, and thermal data, creating a living digital twin of the bridge for real-time health monitoring. Final surface markings and smart traffic systems are integrated, turning hundreds of individual prefabricated units into a modern transportation corridor. From raw mineral extraction to automated casting and high-altitude assembly, every step in this modular process represents the pinnacle of modern engineering, where geography once posed an insurmountable barrier. Advanced prefabrication turns impossible places into connected realities. This is more than infrastructure, it is the ultimate synthesis of precision, scale, and human ingenuity. FLUXIFY process, perfecting the future of engineering.